We're continuing chapter 7, Other Worlds, an introduction to solar system. When I say other worlds, our world is the Earth. Other worlds, we'll look into other planets, but within the solar system. These days, when we say other worlds, it also means the other planetary systems that are outside our solar system. We call them exoplanets. There are more than 5,000 exoplanets that have been discovered so far outside our solar system. We have 8 planets here. There are 5,000 other planets orbiting different stars. Some single star. There are also many planets that orbit binary stars, 2 stars, like Tatooine, like in Star Wars. There are even planets that orbit that are in the trinary star system, 3-star system. Okay. But first we'll look into the solar system, basically the overview of our planetary system in the solar system. In this chapter, we'll describe how the objects in our solar system are identified, explored, and characterized. Describe types of bodies in our solar system: big bodies, rocky bodies, gaseous bodies, asteroids, comets, and the important question in this chapter, or while studying solar system, is that why we're trying to explore, or why we want to know about the planets. There can be multiple answers. One is the curiosity. We just want to know what's out there. In the 15th and 16th century, people in Europe, Asia, and America were curious what's next to their country. Those people who lived in the coastal line of the Pacific, they wanted to know, if you continue travel, if you just keep on going on your boat, row your boat all the way, they were curious how far you can go or what's out there. Right? That's how America was discovered. Just to, the curiosity, to know what's out there. People in the mountains wanted to cross the mountains and see, what's out there, what's behind that mountain. Right? That 15th, 16th century, those expeditions led to discovery of new lands, new mountains, new oceans, new lakes. And that curiosity did not stop, and later that reached to the sky, and we started to discover new planets, moons surrounding those planets. And that's one thing. The another thing is that for the purpose of the science, we want to know how Earth was formed. We want to know, is the material that's make up of the moon or other planets is same that we have here. For example, this is the Curiosity rover on Mars surface. The technology helped us to land this object on the Mars. Send this picture. You see, it has dust. You see the tire tracks, same as that we would see on the Earth. There are new rovers trying to collect sample from Mars and bring it back to Earth. Right? Like we did in the 70s, we collected the samples from the moon and brought it to the Earth. And when we tested its composition, we know that, so it's not, the other objects, other planets and moons are not different than the Earth. Whatever Earth is made up of, these stars and these moons and planets are made of a very similar material. As a matter of fact, further analyzing these materials from Earth, Moon, and other planets, we can determine the age of these bodies, how old they are. And now we know that most of our planets, Even the star are about, our sun is about 4.5 billion years old. What was before that? Uh, it was just a lump of gas, cloud, dust particles, mostly hydrogen, helium, floating in the space. And some shock wave sent this lump of gas into a spiral motion, and majority of that gas particle, started to coagulate, fall inside in the central body, and that central body was born as our sun, star. Uh, of course, that evolution takes process millions of years because certain temperature pressure has to be reached inside a massive body so that it can start a thermonuclear reaction, and that nuclear reaction is what's going on in the sun, and the fusion reaction that provides heat and light to us. And the remaining bodies, the remaining gas and dust during the formation process that rotated around that disk, that coagulated separately in the form of planets and moons. And now we know that our solar system has, all that gas, dust particles have now mostly settled, and we have a very clean structure. We have a central star, a very stable star, giving off light at constant rate. It's quite stable compared to some other stars, which can be very unstable, meaning they can they can give off radiation at much larger scale than living things can handle. Sun is pretty stable. Our planets are pretty stable. They orbit around around their orbit once a year for Earth. We don't see any violent collision with asteroid and comets every day. In the beginning, when in the formation stage, there were these rocks, asteroid, comets flying over everywhere. We can see this in the moon. Moon has so many craters. Even Earth has all these craters that we see that happened millions of years ago. Those craters were created by these randomly flying asteroids and comets hitting the Earth. And now they have settled down. But every now and then you'll still see, we still get comets, asteroids flying around us. And so our solar system basically consists of sun, the primary body. It has planets. Planets have moons, rings, and other we call debris like asteroids, comets, and dust. Some asteroids are as big as Pluto, so they're not debris in that sense. And the mass wise, this is interesting. So if you look at the mass, if you measure the weight, the mass of every object in our solar system, the sun carries 99.8% of the total mass of the solar system. And we know how big Earth is, how massive the Earth is. And Jupiter, how massive Jupiter is, Saturn is, but all that are negligible compared to the mass of the sun. Sun is that huge. And next to it is Jupiter. So 99.8% is sun, and Jupiter carries 0.10%, and that's 99.9%. So only 0.1% is carried by rest of the planets, including Mercury, Venus, Earth, Mars, Saturn, and all these objects in the region we call Kuiper belt, or these objects are TNOs, trans-Neptunian objects, the objects that are outside of the Neptune. So here the blue lines are the planets, 8 of them. Here is Ceres, one of the big asteroids, one of the biggest asteroids in the asteroid belt between Mars and Jupiter. And others, these are all dwarf planets or asteroids that are outside of the Neptune. They are quite inclined orbit, quite eccentric orbit. And here is the reason why Pluto was demoted to dwarf planet from planet, because there are other objects like Ceres, Aries, for example, have very similar size to Pluto. So if we continue calling Pluto a planet, then we would have to add all these other dwarf planets. And so then scientists, astronomers came together and they set a line, a fine line, and defined what planet should be, based on its size, its orbit. It also has to clear its orbit, but Pluto has not cleared its orbit. There are other objects in its orbit that go along, that orbit along, and also the mass, certain threshold. They set a certain threshold. If the mass of that object is bigger than this, we call this planet. If not, it's a dwarf planet or an asteroid, and that's such. And again, these TNOs that are outside of these Neptune orbits are classified as dwarf planets. To date, there are more than 2,600 TNOs. Only some big ones are labeled here. The blue dots here, these are all TNOs. And this region out here, so the yellow is the sun. These red dots are Jupiter, Saturn, Uranus, and Neptune. These are biggest planets in the solar system, called them gas giants, giant planets. And the gray region here is the Trojans, Jupiter Trojans, these little asteroids, debris that are in the Jupiter's orbit. And this outside region, this is called the Kuiper Belt. These are Kuiper Belt objects. These are outside the Neptune's orbit. So these are trans-Neptunian objects. And as you can see, the range, this is at 0 AU. The sun is at 0 AU. Sun-Earth distance is 1 AU. AU is astronomical unit. It's a different system of measuring distance in the solar system. We set whatever distance in miles, meters, kilometers between Earth and Sun. We call that 1 AU, and from there we measure the rest of the distances. And about the size of the solar system, the outer edge of the Kuiper Belt is about 40 AU, 0 to 40 in radius, so that's about 80 AU in diameter. That's how big our solar system is. And these planets orbit in a very funny way, at least the rotation axis of it. Remember, Earth's rotation axis is tilted about 23.5 degrees to the ecliptic plane. This tilt here, but our Earth rotates in the same way, same direction as the revolution. But if we look at other planets, some of them orbit in a very funny way. Mercury is 0 degree tilt, orbits in the same direction as the revolution around the Earth. We call these orbit prograde orbit. Some planets orbit, if you look from the top, some planets orbit clockwise direction, while they orbit around the sun in the counterclockwise direction. So the revolution direction and rotation directions are switched, are different, and that is Venus. Venus, we call the motion of the Venus retrograde because again it rotates in this direction clockwise when you view it from the top, but its rotation around the sun is counterclockwise when viewed from the top. 25 degrees for Mars, Jupiter, Saturn, Saturn similar to Earth. Jupiter is quite, almost 90 degrees and goes in the prograde. Saturn is prograde. The planet Uranus, it's funny, it's tilted all the way 90 degrees. And so Uranus rotates like this in the horizontal rotation axis. Others are mostly vertical rotation axis, but Uranus is in the horizontal axis like this one. And Neptune is tilted 28.3 degrees. So the world out there is full of surprises and interesting facts. We can fit 1,300 Earths inside a Jupiter. That's how massive Jupiter is. And all these four planets, Jupiter, Saturn, Uranus, and Neptune, these are called gas giants or four giant planets. Called gas giants because the majority of the composition of these planets, the outer layer are hydrogen or helium. Inside all of these planets, they have a small rocky core inside of it, but majority of the mass comes from the gas envelope. And Jupiter is also called a failed star. A failed star because it did not have enough mass which could create enough gravity, enough pressure at the core to start the thermonuclear reaction. And during the formation process, most of the material went into the star and the remaining material started to form planets. Sometimes when that bigger, the lump of gas is so massive, 1,000 times, million times massive than the sun, in that case, there can be more than one star born. That's how the binary stars and even trinary stars are formed. But in this case, the mass, the overall, material during the first phase of the creation, it was small enough that most went to form a star, our sun, and the remaining was taken mostly by the Jupiter, but not enough. So when you keep on adding masses to a planet, what happens, the internal pressure starts to increase because the gravity is pushing everything down, so that the core, at the center of a planet, the temperature and pressure start to increase. And when enough temperature, I believe that's 10 million degree Kelvin, when that temperature is reached, then you can fuse hydrogen. Fusing hydrogen means two hydrogen atoms are fused together to form helium. One proton creates two protons at the nucleus and two electrons outward. That's helium. And in that fusion process, heat and light is given off, and that's what we receive, from the sun, because the sun could reach enough temperature and pressure. Jupiter, not enough mass, so it remained a planet. So it does not have its own way of producing light and heat. Yet it is massive enough, and its envelope out here, it's all mostly hydrogen and helium gas, pulled together, kept together by the gravitational forces. And these eyes here, these are like super tornadoes, super cyclone, or hurricane of hydrogen and helium that rotates. These colors here, there are movies taken by the spacecraft. As they rotate, the rotation speed of the inner core and outer gas is different. So we see these clouds, rotating. And this is the largest eye, the hurricane eye, observed. We can see this from Earth with a small telescope. Other interesting things, like all of these four giants have rings. Like this one here, it's just the Saturn's ring is massive, huge, lots of debris, millions, billions of debris from dust particle, gas particles, to the size, the rocks, asteroid size that are bigger than mountains. Different size particle. It does look smooth when viewed in these type of pictures, but it's quite rough there. If we look in detail, when we studied Saturn and planets in more detail, I'll show you more images of the rings. But again, since the rings here, this constitutes a much large number of debris. They are visible from Earth, a most stunning part of the solar system, I think. However, these other objects like Jupiter's does have its own ring, but the number of debris particles are less, so it's not as visible as for the Saturn, and same thing for Uranus and Neptune. And the one we demoted to be a dwarf planet, Pluto. Pluto was the last discovered one. It was discovered in Lowe's Observatory in Arizona in 1930, not long ago, little less than 100 years. And its distance, average distance, is about 39.42 AU. You know what AU is? It has quite eccentric orbit, 0.25 eccentricity. So it's quite elongated, the orbit, so it can be as far as 49 AU. And at its closest distance, this is the aphelion. This is this is the aphelion. This is the perihelion. So apoapsis and periapsis pass, the shortest pass in our ellipse. Sun at the focus. So the nearest distance can be 29 AU, farthest 49 AU, average about 39 AU. It takes 248 years, 250 years, give or take, 250 years to go around once. It was discovered in 1930, so poor guy even hasn't made one complete revolution, and we demoted it. Inclination, it's very eccentric, the orbit that you saw. All our other 8 planets are almost in the same plane, maybe up to 4 or 5 degrees, but this one is at 17 degrees inclination. And this is a trans-Neptunian object or a dwarf planet. And it does have all similar structures that we see on Mars or even on Earth. It has all these impact craters. When big asteroids, hit these things, create these craters. We have observed this in our. There's one in Arizona. There's one in Mexico. I think that's the biggest one that wiped out all the dinosaurs. And these are some more facts about the planets Mercury to Neptune. Distances are measured in AU. Again, for reference, Earth-Sun distance is 1 AU. Revolution period, it takes 1 year. All the times are measured in terms of Earth year. 0.24 years for Mercury, that's the shortest orbit. The longest orbit is Neptune, takes 164 years to go around. You can compare the diameters, 142,000 kilometers, Jupiter diameter. Most massive, 18,991 kilograms. As you can see, density is quite low for Saturn, Uranus, Neptune, because they have most of the material in the gas giants are hydrogen and helium. Gas have much smaller density compared to the solids or the rocks, dust. So for that reason, these four planets, Mercury, Venus, Earth, Mars, um, they are called rocky planets. They are mostly formed of rocks. These are called gas giants, and hence their density is much bigger. Actually, Earth is the most dense planet. There are other smaller members in the solar system, 8 planets that we know. They have moons. We know 210 known moons. Earth has one, uh, and Mars has two. Mercury and Venus are the loneliest thing in the universe. Poor guys don't have any companion. They just roam around the space on their own through hot temperatures. And some of the largest moons are as big as the planets, the dwarf planets. Galilean moons, we call 4 major moons of Jupiter. Galilean moons are called Io, Callisto, Europa, and Ganymede. Other larger moon like Saturn. Saturn has the largest moon, Titan, and Neptune had confusing name Triton. These are the biggest moons of Saturn and Neptune. These moons have their own. They are the world in itself. For example, my favorite moon is Europa in the whole solar system. Europa has a very ice layer outside of it. It's all ice, and it is believed more testing is need to be done. Hopefully, we can send some rover to Europa and dig inside. It looks like that icy core is about the icy layer is about 50 kilometers, and underneath it can have liquid water present, and who knows what lives in those water. But so far we have seen cracks in this icy layer of the Europa. Very interesting object to discover to discover more in the future. Europa, one of the moons of Jupiter. And these are the Saturn of the rings in Saturn. Very pretty color, different material, hence different color. There are gaps in these rings. Some gaps are huge, some are narrow. This image was taken in 2007. I'm sure there are better images than this. I'll show it to you in the future. And here, I want you to memorize all the moons of Saturn, Uranus, Neptune, and Jupiter for test. So Earth here, Earth's moon is here. This is, not to scale as you can see. Mercury and Venus, no moon. Earth. The name, I say moon. Usually, we write capital M, and moon, that's the natural satellite of the Earth. That's the moon that we usually say, the moon. Other are small letter M moons, or we also call satellites, and natural satellites. There can be artificial satellite that we launch. So all other, these are satellites of other planets or moons of other planets. So that's why we say moon. We also call moon Luna, Luna, Luna. And here Mars has Phobos and Deimos. And Ceres is one of the largest objects in the asteroid belt. Others are Hygiea, Juno, Vesta, Pallas or Pias. Triton is the largest moon in Neptune, and Saturn has Titan. Uranus has Titania, just called Titanic, why not? Pluto has 5 moons. And as you can see, Jupiter and Saturn have the most number of moons out of those 220 known moons. And there are more. Okay. The asteroids are not satellites, yet they are some of the biggest objects in our solar system. They are trapped in between Mars and Jupiter. Mars' huge gravitational field is stop them from randomly roaming the solar system, and who knows, some of them can escape and hit the Earth, and that has happened in the past. But Jupiter controls these asteroid belt objects. Some of the moons look like this. So this is actual Earth. This is actual asteroid called Eros. Small Earth crossing asteroid image was taken by Near Shoemaker spacecraft from 100 kilometer altitude. This is 10 kilometers wide. But the moons of Mars, they are moons of Mars. They're not circular. They are not massive enough. Usually more mass results in a circular object. They are not that massive. They don't look circular either. They don't look like our moons when you say moons. So some of these asteroids can be captured. When they come closer to the planet from outside, or maybe from asteroid belt, from Kuiper belt, or maybe from outside the solar system, and they come around, and if they enter the gravitational field, and these objects can be captured as a moon, as a satellite to orbit around the planet. And this is what is believed. The Mars may have captured these 2 asteroids around its orbit, and by definition we call these satellites, or the moons of Mars, or captured asteroids. Bigger planets do that often. Jupiter and Saturn have captured, many of its moons. And some are formed within the disk. When star is born and when solar system is born, when planets are formed, the materials that form the planet, the remaining material after the formation of the planet, that material can coagulate together in the form of smaller bodies, and that's how moons are formed. But sometimes these other random objects in the solar system may be captured by the gravitational potential of the planet, and they can remain there as a planet. So moons can be formed or captured. And other objects in our solar system are comets. They're mostly ice made of frozen gas, water, carbon dioxide, and there are remnants from the formation of the solar system as well.